Hello guys, welcome back to mathematics. Today we're going to check how to solve inequations. And I think the best way is to compare it with the solution with equations. So I'm going to start setting an equation and an inequation without any unknown variables, just for you to check what is the mechanic of the operations. So for example, we have 5 equals 5 as an equation, with an equals in the middle, and an inequation would be, for example, with the sign less than. So this one says 3 is less than 5. They are both true statements. 5 is actually equals to 5 and 3 is smaller than 5. So usually when solving equations, we do the same operation both sides. So the given result is still the same. Let's see if it works the same in the inequations. So let's say that we add 2 both sides. In both equation and inequation, we get 7 equals 7, so the statement is still correct in the equation, and 5 is smaller than 7. That's also true in the inequation. So we are safe if we add both sides the same amount. Let's see what happens if we want to subtract. So same equation and inequation, and this time we subtract 2. So we get 3 equals 3. This is still true. And 1 is smaller than 3. It's still true, so it works. We can also subtract an amount both sides and keep the equation and the inequation too. Let's see what happens when we multiply. So when we multiply by 2 both sides, we get 10 equals 10. It's the same thing in the equation as we expected. Let's see in the inequation. 6 is still smaller than 10, so it works. But let's say what happens when we multiply a negative number. So it's still same equation and inequation, but this time let's multiply by minus 2. So in the equation we get minus 10, which is equals to minus 10. No problem, we can do it. But in the inequation, notice that we get minus 6 is smaller than minus 10. That is not true. The truth is that minus 6 is actually bigger than minus 10 because it's on the right in the number line. So guys, we can't multiply a negative number both sides of the inequation because in that case we would have to turn around the sign. So notice that in that case, if we do it, we just need to change less than by greater than. So if you change the sign, then you could keep going with the inequation. You just need to be careful to do the change. And let's check that actually also happens in the division. If we divide by a positive number, the equation is still correct, and the inequation too. 1.5 less than 2.5. We can do it. But let's see what happens when we divide by a negative number. Negative both sides, the equation is still correct, but the equation has also a mistake. In this case, it's wrong. Minus 1.5 is actually greater than minus 2.5. So notice that in this case we also need to change the direction of the sign. Less than converts into greater than. But what happens when we want to solve, for example, this inequation? In this case, if you were talking about an equation, you would multiply by x both sides, so it's not going to be in the denominator anymore, right? But if we do it here in the inequation, we don't know if x is positive or negative, so we don't know if we should keep the sign as it is or we should change it. We don't know which one is the correct one. So guys, be very careful. When you are working with inequations, you cannot multiply or divide by the unknown. This is very important. So what we should do? Well, we go back to this one later. Let's start solving some of them that they are a little bit easier. So for example, this one, 5x plus 2 is greater than 4. As in an equation, we want to leave the x alone. So I'm going to start canceling this plus 2 by subtracting 2 both sides. So we could cancel them out here and we would be left with 5x is bigger than 2. And then we divide by 5. That's a positive number, so we have no problem with divide by 5. X should be bigger than 2 over 5. This is the solution of the inequation. Notice something very interesting too, as a difference with the equations. In the equations, we usually get a value, but in these ones, we actually get an interval. This means that the solutions are all the values for x that are bigger than 2/5. That means that if we are in the number line, we have the 0 and the 2/5 here, let's say, then the solution are all the numbers that are bigger than 2/5. Why did I leave this hole here? It's because the 2/5 is not included. If we wanted x to be bigger than 2/5, then it cannot be 2/5. So the correct representation would be like this. So the solution is actually an interval. An interval of numbers, all the numbers that belong to this line here. We can also write it in the interval notation. So you could say x equals to 2/5, comma, infinity. This means that the solution are all the x that comes from 2/5, but without including 2/5, to the infinity. Let's say that this is not greater than, is greater or equals to. Then in that case, the 2/5 would be included, so we fill this point here, and this would be written with a box parenthesis like this, 2/5 to infinity. So this tells me that the 2/5 is actually included. Another way that we could write it is, for example, x that belongs to the real numbers. So x is bigger or equals to 2/5, like the actual answer that we got. That's another option. Let's see another example. Sometimes the x appears in both sides, just like in the equations. So we would do exactly the same. We would add 3x both sides, so the x are going to be on the same side. Remember that we can add or subtract numbers, so it doesn't matter if x is positive or negative, we can subtract it or add it both sides, and the sign of the inequation is not going to change. So here they get cancelled, so it's going to be 7 is smaller than 13x. Finally, we can divide by 13, both sides. It's a positive number, so it doesn't change the sign, and the solution is going to be x bigger than 7/13. As an interval, we can draw it as, let's say the 0 is here, the 7/13 is somewhere here, and the solution in this case includes the 7/13 and all the numbers bigger than that. This means that it keeps going to the infinity. Or we can also write that x goes between 7/13, remember the square box is to include the 7/13, and it goes to infinity. Infinity is always going to go with a normal parenthesis because it's not a number, we cannot include the infinity, so it's always going to go with a round parenthesis. Let's check this other example when we have actually two signs. In this case, we want to leave the x in the middle, so we are going to subtract 6 on the three sides. So we could cancel it here, so it's going to be 4x has to be bigger than -4 and smaller than 44. And finally, we can divide by 4. So -1 is smaller than x, which is smaller than 11. So that means the solution of this is going to be the numbers between -1 and 11. As an interval, we would see it like this. Here is the -1, the 0, and the 11 over here. And the solution is all the numbers, but we don't include the -1 and we don't include the 11, so it's going to be a hole there. And we'll represent it as all these numbers here, all of them. As an interval, we could write it as -1 to 11. They are both not included, so that's why we use round parentheses. And since a promise is a theft, let's see how to solve this one that we said at the beginning. Since we cannot multiply by x, then how could we do it? Then we need to consider the two scenarios. We need to consider when x is smaller than 0 and when x is bigger than 0. We don't consider when x is equals to 0 because we cannot divide by 0, so x equals to 0 is actually impossible. And then we solve it that way. So 1/x minus 5. If x is negative, then when we multiply by x, we can do it, but we need to change the sign. So it would be 1 bigger than 5x. And then we divide by 5. To get x has to be smaller than 1/5. But notice at the beginning we said x is negative. So all the negative numbers are smaller than 1/5. So basically any negative number is going to be a solution. And let's see what happens if x is positive. Again, we would have the same expression. But then when we multiply by x, we don't need to change the direction of the sign. It would be just 1 smaller than 5x. When we divide by 5, we are going to get x bigger than 1/5. So the solution is the two intervals, x smaller than 0 or x bigger than 1/5. So as an interval is going to look something like this. We have the 0 and the 1/5. So we saw that any negative number is a solution. So we leave a space there and include all the negative numbers to the infinity. And then x should be bigger than 1/5. And also we don't include the 1/5. So another whole and the solution are all these. So all of them are solutions. As an interval, you can write it as the union of these two intervals from -infinity to 0, open, union with from 1/5 to infinity. And that is the solution. Okay guys, this is your time to practice. Try to solve these ones. Leave me the answers in the comment box that I'm going to check your answers. Okay guys, that was all for today. Don't forget to subscribe, book your own lessons with me if you still have doubts, and let me any question or any topic that you want me to explain in the comments box. Bye bye guys, see you next time.